components of GIS and the things that we are using GIS for now and the things that we hope to see GIS do in future, it means that there's a very powerful tool that we can leverage in every aspect of life, whether it is in the health, in engineering, in transportation, in logistics, everything GIS is applicable, especially considering the fact that the basic data of GIS has to do with location. And we know that as we are on the planet Earth, we are on the surface of the Earth, everything has location, which means that everything we can work with in GIS. So think about that alone, you see how important and how strong the tool is. And it's sad to know that most institutions, especially the very big institutions around us, do not appreciate or know the extent to which GIS can make things very easy for them, or even help them generate more revenue or help them in their decisions and everything. So it is good that we are here. And after everything, we'll go out there and then be great ambassadors of GIS. Please, if you agree with me, I want to send an emoji or something, interact with it. I want to see some interactions. Oh, I'm not seeing anything. Okay, so thank you. Thank you. Yeah, I'm seeing it. I'm very happy to know that we are all involved and actually very attentive. So let me just go straight to introducing our facilitators. We have two very important. Hello, please, did someone say something?
No, please go ahead.
Thank you. We have two very special, very important persons to handle us, to facilitate our section today. And trust me, we are privileged to have them because looking at their portfolios, these are people that have great experience, and we are very much privileged to learn from them. So our first facilitator, GS Richard Chebafo. GS Richard Chebafo is an experienced senior geospatial solutions expert with a demonstrated history of geospatial solution implementation and client relationship management. He is skilled in translating customer needs, business goals, and requirements to workable and state-of-the-art long-term solutions with huge return on investment. His expertise spans across the web and enterprise geospatial technology, spatial data management, spatial analysis, development of ODKs, and other spatial data collection tools and location-based services. GS Richmond's proficiency in geographic information system, remote sensing, data management, and spatial analysis has successfully led cross-functional teams in the delivery of various geospatial solutions in electric and water utilities, agriculture, telecom, built environment, and local government industries in Ghana and the West African sub-region. In the past 15 years, he has been trained by some of the top geospatial industry leaders like Esri Incorporated, Trimble, and has built his career in geospatial and GNSS technologies in the United States of America, Europe, Middle East, and Africa. He holds a bachelor's degree in geomatic engineering from the Kwame Nkrumah University of Science and Technology and has a master's in management information systems from Coventry University. He is a professional engineer with the Ghana Institute of Engineering. He works with Spatial Limited, a GIS and IT firm in Ghana with footprint in Anglophone West African sub-regions. Please, with some love, let's show some appreciation for GIS engineer Richmond Cheba before I continue.
Thank you very much, Priscilla.
Thank you, GS. Please, the floor is yours.
All right, thank you very much. And a very good evening, good afternoon, and good morning to all our participants all over the world. And I'm privileged to have you sit in our meeting, sit in our class. So I'll take the battle or the baton from here. And I think that I must say that our moderator has virtually delivered my material for today. And at this point, I might as well say that we can close the session and have the next session another time. But if that's said, I would want to continue and then have what we have on our plates today. So if you indulge me, I would start by sharing my screen and then we can get started. Right. I would be going on and off video so that we can have the full benefits of the internet connectivity. We don't want a situation where we would have to have some distortion in our internet connectivity. So if you see me off, just be patient. But I hope to be on throughout the session and it will be good. Okay, so at this point, I would want all of us to mute our microphones. I will indulge all of us to mute our microphones for us briefly. It's going to be a very short session, and then we can turn them back on. Right. Thank you. What we have today, basically, I'll be handling the basics of GIS or GIS basics. And GIS basics is part of series of materials that we'll be delivering, hopefully this quarter of the year as part of our CPD program for the year. And it stems from the main theme or topic, which is Introduction to GIS. And we are taking the first session, which is GIS basics. Please, if you can't hear me, you can just give me a heads up. Right, and occasionally I am located right under the flight path when you are landing into Kotoka or you are coming into Ghana, close to the airport. So occasionally you hear some noise at the background from the flight path, right? So let me share my screen again. I understand you are seeing my main screen. Okay, great. So for today we have, let's look at what we have for the series. So introduction to GIS series, we're going to be handling GIS basics, which I will be handling today. We'll have spatial data and data sources, which will be handled by my other colleague, that is John Esiama. We'll also have introduction to GIS software and tools. We'll have spatial data analysis. Spatial data analysis. Right, so for the first section, which is basic GIS or GIS basics, we'll be looking at what GIS is. We will look at fundamentals of GIS, concepts. We'll look at the importance of GIS, which my moderator has done justice to part of it, almost part of it. We'll look at the component of GIS, spatial data types, introduction to some GIS tools, and specifically we'll be handling the ArcGIS Pro and then the Quantum GIS, right? We'll have a question and answer sessions where you will be allowed to either type in your questions in the Q&A section within the Zoom application, or you can also unmute and then you can ask your questions, right? So when you get there, I would reiterate these instructions as well, right? GIS, yeah, what is a GIS? Basically, from where I sit, there are about 3 or 4 school of thoughts, but that's actually define or gives us a good definition of GIS. Some will say that is a technology that is used to create, manage, analyze, and also map all type of data. So that is one school of thought. The other school of thought said that GIS connects and map and integrates location data. That is where things are on the surface of the earth with all the types of descriptive information, which a lot of us know as either the attribute information or the metadata, or both. And this provides foundation for mapping and analysis that is used in science and almost every industry. So that is the second. The third school of thought says that GIS, which is Geographic Information System, help users to understand patterns, relationship, and also add geographic content. GIS helps us to understand patterns in our data, relationship that exists amongst or between data sets, and then also our geographic content, right? So GIS, as we have initially defined them, or given the 3 different definitions, actually helps us to benefit from a lot of things with respect to our data, including improved communication, efficiency, management, and decision making. So when you are applying GIS, you can effectively communicate what your data is within your business unit, and then also manage information within your business units. And then most of all, help with decision making by top level management. Simply looking at the data in tables and rows will not afford you the opportunity to make a lot of decisions or insights from the data. However, when you put the data in a GIS environment, then you have the capability, you have the opportunity, well informed as to what you can make from the data, what the data can assist your organization or your business unit to do. What does GIS actually do for us? What does GIS actually do for us? So 1, GIS helps with data management. So with GIS, you can actually manage your data. And we said that data, as the moderator indicated from the beginning, it's actually the foundation system of records, or it forms the basis for your GIS system. And information from business systems and other authoritative sources can be stored and integrated together. to help you make useful and meaningful decisions. Right. So one of the things that GIS can help us do is to manage our data, either spatial data or tabular data. So we'll look at, later on in our discussion, we'll look at the various data sets or the various data types, and then we'll go into each one of them. Then the second thing that GIS helps us to do is basically to be able to visualize and then also see all your data in a form of a map. So from 3D digital mapping or dashboard views, you are able to bring your data, all right, to life. So data is brought to life through the power of GIS. Bring your data to life simply means trying to communicate whatever information you have in your data across the business unit. And the organization is able to effectively take decisions based on the type of data that is ingested into the GIS system. So this ranges from satellite imagery, drone data, vector and raster data, and then the like. So here we have various data sources making up or giving us an opportunity to be well informed as to what is where. So we have smart cities where we have some buildings, structures or features of buildings. We also have features of a location like a terrain. We can have features of vegetation, also alike. All these is made possible by the power of GIS. So that's what GIS can help you do, mapping and also visualize your data in a form of a map. Then the third thing is data analytics. Data analytics. Now, it's one of the big things but data is one of the powerful dimensions we have in the world now. If you take out money and then the others, data. So if you have data, you have power. More also, if you are empowered to be able to analyze data or provide a lot of data analytics into your data, then you become very powerful. So you are able to inform your management, you are able to inform the business unit as to what is happening within your business unit with respect to activity based on the data that is churned out from that business unit. So everything happens everywhere, as you would say. So with the required spatial analytic tools, you are able to make a lot of decisions based on or revealing the hidden relationship and patterns within your data. And this basically you can generate what you call insights into your data and share with management. So for instance, before you get to the application of GIS, for instance, if you are a business like a bank or a banking institution and you want to cite a branch elsewhere, with GIS, you'll be able to gather some data, spatial data and tabular data. And then with the analytic tools that the GIS system or application presents you, you'll be able to perform what you call suitability analysis or siting analysis. And you'll be able to know where to place a branch so that you can get the required investments you have made or return on the investment you have made in citing that bank branch within a particular place. That is what GIS allows you to do. So the next thing is communication. Now, if you have a data sitting down on a drive, you have data sitting down on your computer, and you are not engaging the data, then that data becomes meaningless. That data becomes unuseful. But once you are able to engage your data with GIS, so GIS also serves as a system for engaging your data. So we say it's a system of engagement. So with GIS, you'll be able to develop a map, share the map within the business unit, and communicate some kind of analytics to either top level management or within your team. And that will help them with a decision that needs to be made or not, that needs to be taken. So informed products such as maps and dashboard also communicate a lot of information to users. And you cannot just infer these decisions or infer these analytics and infographics from just a tabular data. You'd rather it would be easier for you to have this kind of data ingested into a GIS system to be able to give you such information. So here we have dashboard that is giving you some indicators. So for instance, road conditions of a particular place. You have data on roads. You have taken data on a particular road or some classes of road. So this data would include, or information about the spatial data include the type of surfacing of the road, the type of road infrastructure that is on the road, and even when the date or the year on which in which the road was constructed, which engineer did what, so that if there are problems and you need to recall, you would easily be able to recall that particular engineer to come back to the road and then fix the problem. So all these engagements, information, decision taking is made possible when you have your data in GIS. So that is what Geographic Information System affords you to do with your simple organization data. All right. So we look at some of the fundamental concepts of GIS or Geographic Concepts. So the first one, we said that the concepts are basically the fundamentals or the foundation principle that enable us to effectively collect data, store this data, analyze the data, visualize the data, and also interpret patterns and also relationships that exist in the data. So one of, or some of the concepts that we'll be looking at includes location. So we say that on the surface of the earth, unless you are not on the surface of the earth or on any of these universal masses like planet, everything on the surface of the earth happens somewhere. So then your location becomes one of the geographic concepts to consider in GIS. So your location either is an absolute location, which is your X and Y, or is a relative location. So for instance, my location where I am now, I can say that I am located in point, let's say A, okay, closer to, let's say, the motorway, closer to the shopping arcade, closer. So this is a relative location. So it is not so precise. Unlike you have your latitude, your longitude, your eastern, and then your northern, that gives you your exact location of where a feature is located. So location is one of them. And then also another concept is your geodatabase. What stores the data? So the geodatabase is basically the structure that is used to store query and then also to support other data functions like versioning, relationship, spatial indexing, and all that. We'll get there very soon. So some of the key concepts include one, location. I've spoken about it. GIS application, it is very key. So GIS is without GIS if you don't have an application in place. We have spatial data and spatial data modules. We'll be looking at that pretty much soon. We'll look at the GIS software and then tools, the geoprocessing tools, the geoanalytics tools. We also have the database, which we call the geodatabase. It is geo because it has the XY component. We have layers. Layers is one of the concepts that we need to look at. We have attributes. So these are information about the spatial data or information about the feature with respect to whatever data that is being collected. We have spatial analysis. I've spoken brief about it, where you need to look at maybe a suitability analysis, proximity analysis, and all that, buffers and all that. Then we have map design and visualization to crown it. Now, these are some of the concepts that we need to consider when we are looking at GIS. Right. Now, how is GIS used? How is GIS used? And a lot of the time, We know GIS as trying to display data or some sort of data on the map, or to create some kind of hard copy map or paper map and then place it on a wall with some pins indicating locations of where features are and then also their relationship and all that. But GIS does more than that. We say that GIS application GIS can be applied from archaeology to zoology, right? So it cuts across all industries. So from startups, from schools, non-governmental organizations, citizen engagement. If you want to actually crowdsource information, so for instance, crime, locations of where crimes are. If you have a GIS application, you can easily source data from the citizen or the citizenry. And this will inform maybe the police, the security services, we will, inform in terms of strategy, in terms of planning and all that. And that is all made possible by the application of GIS or some sort of geographic information application. Utilities, water utility, electric utility, telecom, other businesses. And now we use GIS in finance, banking, then local governments. So where we are looking at sanitation, where we are looking at management of street light, management of telephone poles, management of even roads infrastructure. Now, all these is made possible by the application of geographic information system. And we said that it provides an open platform for collaboration and innovation. So it informs citizenry, it informs opinion leaders as to the next step to take, what to do in terms of infrastructure management, in terms of any sort of situation as it presents itself, be it crime, be it tactical planning for the defense and military, and all that. Great. So let's look at some of the application areas. So the first one is the built environment. So we can use GIS for one, space utilization, where you need to look at which spaces are available, where, and then what can be planned in this space. All right. Transit station design. So here we don't have, in Ghana, we don't have a lot of these stations, or yes, transit stations. So where we have, if you go to other jurisdictions where they have well-planned transportation system. So the areas or the infrastructure around these transportation system are well designed and planned using applications like GIS. Proposal reviews, smart cities, campus navigation. So if you go to some campuses, you don't even need to ask anybody which department is located. All you need is an application, even if you are not presented with a map of any sort. And I mean a map, like a hard copy map or some sort of a map inscription. You can have a simple campus app that is on your phone. So let's say you are a fresher, you enter the university, you want to know your way around it. All you need to do is to download an application that an institution has developed, like the Campus Navigator, which some institutions have. And this will help you navigate your way around the campus, way around the institution without any problem. Redevelopment planning. So if you are planning a city, so for instance, we are looking at a motorway expansion. That is a kind of, that is a typical example of redevelopment. We're looking at houses or buildings that are located around these highways or motorways, how to redesign them if you need to move them away, if you need to provide the alternate route, and even helps you to redesign your road in a way that will not affect commuting and also settlement. So these are some of the applications. Cartography, that is a big one. So national mapping, sensors, aeronautical maps, conservation map, military cartography, and all that. These are all made possible with application of GIS. So you want to know how many people are located in a particular vicinity or area. You need to deploy some sort of GIS application, conduct sensor for demography, collect a lot of spatial data, both spatial and then tabular data, that would inform you to plan, even as a government, economically, right? Environmental monitoring and assessment. So here we are looking at ecological significant areas. So areas like the Ramsar site here in Ghana, where it has become an area for development by a lot of people. If the city is well planned, then you know that these areas are reserved ecological areas that do not need to be touched because they have very critical ecological significance to the environment. So you make sure that these areas, once they are mapped out and you protect them, they can easily be conserved. Unlike we have it where people are building house structures into these zones. Noise modeling, you don't have that here a lot. I did mention from the beginning of my presentation that occasionally you will hear the noise of aircraft landing in the airport. So there's a typical example of noise that those of us that are located close to the airport, we are faced with. That noise can actually be modeled, right? And then we look at how to even redevelop the areas around the airport so that these noise pollution can be kept or controlled minimally, right? So you look at the kind of houses that need to be built because of the noise, the kind of material that should be used for these houses. These are some of the application areas. Groundwater changes, pollution modeling, if there is an oil spillage either onshore, right, or offshore, you can actually map out this the disaster, so to speak, and be able to even know the rate of spread of the spillage and be able to curb it and also control aquatic life. So that is one application of GIS, pipeline spillage modeling, sea level rise. So these are all application areas where GIS can be used effectively. We look at developing energy resources. So here we are talking about solar. So where you have an energy mix, like the hydro, the solar, the nuclear reactors and all that, you can actually use GIS to look at areas where you can site your solar farms, areas where you have a lot more sunshine throughout the year. And typically in Ghana, we experience about 365 days of sunshine free of charge given to us by the Almighty. So you can actually use GIS to model up areas where you can have 360 sunshine and then sites what you call solar farms. Same with energy, where you want to have wind energy as an energy mix into your energy production. You can also use GIS to model wind, the location, location of corridors where wind is of excellence or where there is a lot of wind. Okay, so you can actually use GIS to model that, and then you cite these wind veins and then wind wind veins there, and then that would help you to generate the maximum number of or maximum amount of energy that is required to power a particular area or your city. We have hydrocarbon development, we have exploration analysis, well performance, and then of course, offshore production. These are all application areas where GIS can be employed within the energy development resource sector. Managing natural resource, precision agri. Precision agri. This is one of the fields that we don't do much of precision agri, but I am into application of GIS in agri as well. So where we have deployed a lot of M&E tools and a lot of applications to manage the agri value chain. So from production to warehousing to haulage and then also sales, right? One other area is marine protection planning. small-scale farming, small-scale mining, where you would need to know where these activities of small scales are taking place, and also the rates of degradation and devastation, whether they are actually practicing the right kind of mining in terms of small scale. And here I'm not talking about the illegal mining, but these are smaller scale miners, right? And even how to manage and control them. With the application of GIS, you'll be able to know where these mining sites are located and exactly what they are doing. Agricultural modeling, forest management, like the forest preservation project that seeks to actually achieve or seeks to find out which areas in Ghana actually fall within the green belt, and then the rate of degradation of these areas. Now, when you have GIS and with the right kind of data, you'll be able to model out all these forest reserves, the rate at which they are depleting, and what you can do to replenish these green areas of forest. Ocean modeling, I spoke about that. Managing land information, so land information system. So here we looked at property appraisal. That is one area that I have dealt actively in. So we are looking at collection of property rates, looking at valuing the various buildings and the houses within a particular space, and then finding a way to collect property rate and then also manage the kind of buildings within that space. Tax assessments. Okay, so it also falls in the same direction as the collection of revenue. National addressing. We've done some sort of addressing in Ghana. So typically, I think we did Ghana Post GPS, where you have some sort of code. You punch the code into a system, and then you have the privilege of being navigated to a location with ease, right? We have a parcel administration similar to the parcel appraisal, and then property assessment as well. Property management. So where you have a collection of buildings or a category of buildings, and then you need to manage them. So areas where you have high-rise buildings, you even need to look at verticality monitoring and then all that. So these are some of the application areas when we are talking about land information management, right? We also have transportation planning and management. So transit asset traffic modeling, rail commuting, postal delivery, rail management, vessel tracking, routing workers, and then airspace. These are all application areas that we can employ the use of GIS, right? Urban and regional planning, so zoning, land use mapping, urban design, redevelopment, I've spoken about it, community planning. All these are made possible with the application of GIS. Utility and telecommunication. Yeah, so Ghana Water uses one typical institution or organization that uses GIS a lot in their operations. Telcos, the telcos, MTN, Telecel, Airtel, Tigo, these institutions use GIS for their operations. When you talk of the mast management, right of way for some of the masts, and then the like. Customer mapping. We want to know how many customers are located in an area so that they can effectively invest in their infrastructure within that area. Recently, one of the telcos is laying a lot of fiber cables, right? They are doing that based on some analytics they have received from the data that they have with respect to demography, with respect to customers and all that. For instance, if I'm a telco and I cite 20 masts within an area, and at the end of the day, nobody even uses my service, I have really not done so well with respect to my investment. I'm not going to have any good return on my investment. So I need to employ some kind of technology to be able to determine whether to invest such infrastructure in that locality or vicinity to get a kind of investment that I need return on that investment that I pour out there. So all this is made possible with the application of GIS. We have business analysis, and that is one area that now a lot of businesses are going into, like the retail, banking, finance, and even real estate. Now, they want to know how much to invest in an area, and even want to know the income per the population in a particular area, whether if they set up an estate, they'll get people to buy either within the vicinity, especially because they are given much more priority, or will have the market for the kind of investment that they put out there, right? Insurance risk, right? So, for instance, housing or landed property insurance. So, if there is a problem, there is an flood or it rains and then the area is inundated and people's property are submerged and properties are lost, right? The insurance companies need information on how many property have been affected, the values of those property, and then also be able to determine how to even compensate these clients, right? All is made possible by the application of GIS. Right, understanding human health. I was telling you that GIS actually cut across archaeology to zoology. And now here we have it in health, where we have cases of Ebola. I remember I was in one of the West African sub-region and on a project. And just when we were caught up with Ebola, we needed to evacuate and collect some data, all right, to also inform some of the institutions like African Center for Disease Control, CDD, and then some other organizations to be able to look at, for instance, the rate of spread affected and all that. Typical example we have is the John Hopkins COVID-19 dashboard, which we replicated also within our sub-region. So a typical example is that for Nigeria here. So looking at the number of people that were infected, those that were deceased, unfortunately, those that have the disease, the active cases and all that. So all these are application areas of GIS. Infant mortality in some of our countries, right? You'll be able to map all that. And then that will inform either the government or the health institution as to what intervention can be put in place to be able to mitigate all these and then ameliorate these problems, right? Child malnutrition child malnutrition prediction can also be one application area for GIS and health. Public safety and security, and for our group, which is the GeoInt and technology, and that is one key area that we are concerned with. So here we are looking at fire station allocation and location. So in case there is fire, recently in Ghana, there had been a lot of fire in markets and all that. A lot of these fires the fire institutions are unable to control these fires because of other facilities that are not present. Typical example is fire hydrants. So if you are fighting fire and you don't have fire hydrants located close to where this fire is, then it will be very difficult to put out the fire, because when the fire the tenders become depleted of the water or whatever chemical that is used to fight the fire, the next place they look out for is there a fire hydrant close. So with the application of GIS, you can actually map out all the location of hydrants within a city, within a country, and look at fires that have happened in the various places and then look at the patterns or relationship that exists between or amongst locations of these fires and then the fire hydrant or even the fire tender stations. And that would inform as to whether to fully equip the firefighters, create more fire stations, or have more fire hydrants distributed or scattered all over, so that in case there is fire, it will be easy to be able to put out the fire or put out the fire without the fire ravaging and damaging a lot of property. Crime against humanity, so crime analysis, fire responses, fraud mitigation, crime surveillance. I must say that I have done some work within the crime space, within the security services of Ghana, and we virtually use GIS for all that. All right. Auto theft. We don't have auto thefts in our sub-region, but if you go to Europe and other places where people park, they do a lot of on-street parking. Here in Ghana, a lot of us keep our cars in our rooms. So it's difficult for them to be stolen unless there's a deliberate effort to do that. But if you go elsewhere, every car is parked on the street. I mean, they don't provide garages and all that. Even if they do, if they have multiple cars, definitely need to park some of the cars on the street. And these cars are stolen by thieves. So with application of GIS, you'll be able to map the locations of all these incidents. And in some cases, you can even predict when the next car is going to be stolen once you are able to come out with very good predictive analysis with respect to the data that you have at hand. And that will help you mitigate a lot of these menaces, right? Preparing for and responding to disaster. So here we don't have a lot of typhoons, hurricanes in our region, but we have floods. And quite recently, the country had been inundated with these issues, right? So you can actually do flood analysis or flood modeling. You look at areas that are low-lying, areas that easily get flooded. Now the whole country is it's being built up. So areas that are even reserved to collect water, areas that are reserved for some kind of ecological, environment are given out for building. But with the application of GIS, you'll be able to map out all these, look at the various uses of the land, so that you can assign the respective agencies to monitor these spaces so that they are not given out for building. In case there is flood, because you have been able to model out these areas, you know even how to go about your evacuation plan. So how to prepare and also respond to these disasters. In case there is an earthquake, do we have an open space where people can immediately be evacuated to? So this you cannot just envisage and plan in isolation. You need GIS and data, and that is where GIS comes in. That is where GIS comes in. Severe weather, so the meteorological department uses GIS to be able to predict rainfall, predict other weather conditions, right? Air quality is one of them. I was on a project where the quality of air within a particular area is being monitored. Okay, and then that data is put on a map to be able to determine which areas have very bad air, areas that have very hazardous material that are emitting bad, or very dangerous chemicals into the atmosphere, and people are inhaling, right? So we sighted up some weather equipment and then air quality equipment to be able to collect data and analyze this data, right? Citizen alerts. In case there is a problem, let's say there is a natural disaster, there is an earthquake, right? The organization that is responsible, NADMO in our case, would they be able to send some sort of alerts to the citizenry, alerting them, even help them plan and also respond to these disasters. with application of GIS, that can be done effectively without any problem. Of course, the last but not the least is to look at telling stories, success stories with GIS. So we develop an application which we call the Beautiful Places in Ghana. So where we have all the tourist sites with their associated infrastructure like hotels, the roads, and other natural, resources, right? All within one space. So with that application, you can conveniently move from Europe and come to Ghana and then visit this site. It is made possible by the application of GIS. Conduct all sort of censuses, right? That is made possible with the application of GIS. Tell your story. These days, you can actually tell a success story of a project by the use of story maps using GIS. Look at the location of the project, people that benefited, add your media, both videos, audios, write-ups, and then you put all within a GIS environment and present it to stakeholders to tell you the success that you have achieved on the project. And that is made possible by the application of GIS. Open data and citizen engagement. So where we have open portals. So a typical example is the African Geo portal, where you have plethora of data stored in one place, okay, to download, to use for your GIS project and all that. So all this is made possible. The portal can be created using the application of GIS, and it is made possible by the application of GIS to serve the larger GIS community, right? Great. And we say that when we visualize and analyze data on a map, the hidden connection and insights in that particular data then emerges. And that helps you to understand, to engage, to collaborate, and also help with effective decision making. Without that, without GIS, you are just looking at the data in the form of tables, rows and columns, and that will not afford you opportunity to be able to fully engage, fully analyze, fully collaborate, and also make that kind of well-informed decision that the top level management of the team is looking out for, right? So we look at the component. Now we talked about GIS. We looked at some geographic concept. We've also looked at some application areas. Now, what is this? What makes up this GIS we are referring to? What is this GIS? So one, GIS is made up of data is key. You cannot take data out of GIS. That is a spatial data. GIS is, or Geographic Information System, is made up of hardware. So the software, the application sits on a hardware or some sort of a platform. All right. Then we have the application itself, and then the techniques and methodology that we use or apply within the application. Then, of course, you cannot take out the personnel. That is a key component of your GIS system. So the geospatial analysts, the technicians, the decision makers, all these personnel cannot be taken out of your GIS system or implementation. Now, if you take any of these out, what it means is that you do not have GIS. That is what it means. All right. Now, we will handle all the components one after the other. So the first is the spatial data. So we look at the various spatial data sets that you can have within your GIS system. One, when you say the spatial data, we are looking at the real-world representation of GIS data in a digital environment, either in one of these forms. Either you are having your data in a vector data model, which we will be talking about briefly, or you are having your data in a raster data model. So your GIS data can either be raster or it can be a vector. And there are various types of raster data sets and then also vector data sets. We'll be looking at them as we wrap it on. Okay, so we'll first look at vector data models. Vector data models. I must say that I am not looking at the charts. I'll be picking your questions at the Q&A section, right? So that we can move very fast. Somebody said, please, can you make the slides? Provision can be made for it after the class. Okay, great. So I would just want to look at the delivery, then we can look at the questions and then your suggestions and some of your comments in the Q&A session. So the vector data model, I want us to move quickly. So these are digitally, geographically representing your spatial data, all right? Either in these three forms. Representing them, sorry. Either in a points, lines, or polygons. So within your GIS data, like the application areas that you saw some of the maps having lines in them, some of them having some points in them, and then some also have areas or polygons. So your GIS vector data can be represented in these three data formats, which we call the geometry types. It's either a point, a line, or a polygon. In fact, every real-world feature or item that we have on this surface of the earth can be categorized into these three geometry types. You are either a point, a line, or a polygon. And that forms what we call the vector data model. So the vector data model is useful for storing data set, okay, in a boundary way, or your data set have what you call well discrete or defined boundaries, right? So for instance, if you have a point or if you have an area and then the area is well defined, we say that that particular polygon or area is a vector data model. A typical example is a school's compound or an office complex. You can actually map out the polygon area of the office complex using a vector data type called polygon, and that makes it a vector data model. Roads, streets, rivers, and what have you. All these are data models that have discrete boundaries. Discrete boundaries. Unlike the vector where we have the data that have the nature of the data is that they vary continuously. Okay, a typical example is if you take an aerial photo of an area. Okay, if you take an aerial photo of an area, yes, we have what we call vectorized raster data, where the data looks more like a vector, but it's a raster, right? Like a photograph of an area. Okay. We have a satellite imagery. Okay, typical example is some of the application areas where we saw the spillage of oil or the spillage of some chemical or result within a space. Elevation surface. Now, all these are what we refer to as the raster data. They do not have well-defined boundaries because the data changes in nature over time. All right, so they are not definite. The boundaries are not definite. But with vector data model, the boundaries of these data are definite. And we say that these data are stored as points, lines, or polygons. So let's look at some of the vector data. So points, if you have distribution of trees, distribution of buildings, depending on the scale, of course, distribution of, let's say, telephone poles, light poles, telephone masts. These are all data sets that can be picked or collected as points. And we say that this is a vector data set. Vector in the sense that the shapes are well defined, they are discrete, they do not change in nature. The shape do not vary, unlike the other data model. We also have lines. These are well defined. The boundaries are well defined. They start from one place and end at the other place. Right? Then, of course, we have the polygons. So these are some examples, typical examples of vector data models. And these are vector data sets. So we look at some properties of vector data. So one, the geometry type. So vector data model have geometry types. And I did say earlier that they are either points, lines, or polygons. And these, they represent geographic features using discrete objects or discrete boundaries, just like I indicated. Each of these elements have specific attributes. So all the points, the lines, and the polygons have attributes. And attribute information here are the information that you collect about the spatial data. So for instance, if you are collecting data on telephone poles, or we are looking at the type of material make of that telephone pole. Is it made of wood? Is it made of concrete material? Is it made of steel or galvanized steel? That is an attribute, it's a property of the vector data. In this case, the point data that you have collected. We have points. So points, basically, when we want to define what a point is, an attribute of a point is that it's a single geographic location that has X and Y location. So X and Y location basically has, it's a single vertex. Okay, so when you have a point, you have your X location and then the Y location, right? So we call that a single vertex. So a typical example, what we have on the screen is a point data. So we have X and then the Y location. All right, I think I skipped one. So the line is made up of two or more connected XY coordinates or location. And we call that series of points. So we have multiple points that we put together, and each point connotes, or each point actually signifies a vertex. Okay, each point signifies a vertex. And if we have series of these points, we have collection of vertices with X, Y, X, Y, and that makes up a line. So if you look at a polygon data simply means a collection of the point, so a collection of the lines that makes up your polygon data or an area data set. So here we have it. So it is made up of three or more connected XY coordinates or vertices. And your polygon data set should form a loop. I have used some sort of GIS application to collect a collect a polygon data, assume polygon data, where at the end of the day, upon reviewing the data, I realized that it is not actually collecting a polygon, even though you have it as a shape of a polygon or an area. When I run a data review script over that particular data, I realized that the data does not actually close up. So usually a closed or a polygon area has a start point. You go round and come back to the start point to close it. That is the basic fundamental of survey anyway. So for a polygon data, you should always have it in a closed loop. So we have series of vertices that end up in a closed loop that gives us a polygon or an area data set. Of course, a collection of the points, the map, the line, and the area is what gives you what you refer to as the vector map. And for the vector map, is a collection of spatial data sets such as streets, street lights or electric poles, roads, parcels, making up an area. Okay. So here we can have two maps. So we have one, a map of an area. Basically, this is yes, if you are familiar with San Diego, that is downtown San Diego, the first map. And then the second map here is an area of the aerodrome around the airport, Kotoka area. So here, if you look at the two, map 1 and map 2, these are vector maps. Vector map because the features that makes up the map have disparate boundaries. And here you can have a collection of features. So we have points, you can see some point features in there. You can see some linear features in there. And of course, you can see some areas or polygon features in there. So this is what we refer to as a vector map. Right. Now that takes us to information about the spatial data. So when you collect these vector data models or you collect this data, you do not collect the data in isolation because you won't be able to query the data and get the needed information and insight and analytics from the data without another property of the data which we refer to as the attribute information. Some people refer to that as a metadata, but we also have a metadata. So metadata basically is information about the information. So here, the information about the attribute information you have collected, okay, vis-a-vis the spatial data. So it's actually a sort of a metadata of a feature, all right? That descriptive information about your spatial data is what we refer to as the attribute information. And in most cases, these are stored as tables behind the spatial data. So when you go a step back, these maps you see, each of the features there has an attribute information, and that is stored in a form of tables. Later on in our series, we'll be doing live demo and displaying some of these attribute information for some spatial data that will be used for these demos. So that is attribute information. So these are additional information about the spatial vector data that are usually stored in a table, just like I indicated. So a typical example is this. So here we have information about some farmer location or farms. So we have information about the farmer, the gender, the farm ID, and then some other information that is required for the data collection, right? And that is what actually gives us the attribute information. Then again, another table that gives us information about regions where the data was collected, the districts, the type of district or municipality. So either it's a district. Here in Ghana, we have districts and municipalities. So depending on where you find yourself, in which region, you can have both or one of them. Then you can also have information about the capital towns for these districts. And of course, we have their spatial data, the X and Y. So these are what we refer to as the attribute information, and usually they are stored as tables. One other property of our vector map is scalability. It is very important for you to note that to be able to see your GIS data, you need to actually look at your scale preference, because you can have your spatial data in the GIS environment or in your GIS map, and you may not see some details about the data simply because of the issue of scale. We call that scalability. So a scale actually is a representation of a relationship between distances on the map and then also distances on the ground, what we call the real world. Okay, so unlike raster data, when we are looking at the scale for vector data, the raster data, you can simply zoom in and zoom out without losing with the vector data, without losing the quality. In this case, we are looking at the resolution and the accuracy of the data. Whereas if you have a raster data, so when you zoom in to some extent, we'll be looking at some of them. Zoom in to some extent, you lose the quality of the data, or what we refer to as a loss of the data quality, because you have actually scaled the data up so much that the details within that raster data has become blurred or pixelated. But the vector, when you have a vector data, you can zoom in as much as you can, and the data will not lose its quality. So typical example, we have various types of scales. I don't want us to go in depth because here we are looking at the basics. So a typical example here is the scale bar, right? So we have fractional scales where you have your scale as a ratio. So let's look at some of them. The scale types. We have the statement or written scale. So where you have typical example, 1 meter equals to, let's say, 5 kilometers. So what it means is that 1 meter on your map is equivalent to, let's say, 5 kilometers or 10 kilometers in real world or on the ground. So that kind of scale is what we refer to as a statement or a written scale. We also have representative scale or representative fraction, where you have your scale in a form of a fraction, 1:something. So typically, a lot of us are acquainted with this kind of scale from our basic geography or cartography. So we have 1:, let's say, 50,000, 1:100,000, or 1:25,000, right? Then the third kind of scale is what we call the linear or the bar scale, and that is what I showed you initially. Right. So moving on from scale, we'll be looking at another property, which is editability or queryability, whether the data can easily be edited or be queried. Okay, so that is one property of a vector data model, and for that matter, a vector map. So if you have a vector data model or a vector map that cannot be easily edited, then you should know that that data, it is not a vector or yes, it's not a vector data model or a raster, sorry, a vector map. All right. Now, vector data also have what you call weights. So the weight or the size of vector data is most of the time lighter as compared to the rasterized or the raster data set, simply because these data sets are captured in a way that would help you to store more data and also improve on data performance in terms of data processing, data querying, and then also storage. Right, great. So with all the plenty talk, I would want us to look at some quizzes. And at this point, I want to engage my audience just to be sure that you are actually following. So we look at some quizzes, and this is a way of the facilitator getting to know that the audience is with the class or not. Okay, so let's look at quiz number 1. With all that has been said, all the plenty talk. So here we want you to type your question, your answers in the chat box. So if you know the answer when the quiz comes up, just type your answer. We'll look at it. We'll mention your name if need be, and then we'll look at the answers. All right. So 1, the first scenario, UNESCO World Heritage Site. So you are creating a small scale map. I want you to pay attention. You are creating a small scale map of the world for displaying UNESCO World Heritage Sites. So here, the definition of World Heritage Site, basically, these are landmarks or areas that have been designated to have some cultural or historical significance. All right. Now, the question is, if you are creating this small scale map, now the question now is to the geospatialist. The question is, which type of geometry would be most appropriate for this kind of map? Which kind of geometry will be most appropriate? So the word is most appropriate for this kind of map. Is it 1 point, 2 lines, or 3 polygons? So in the next 2 seconds, you can type your answers. Let's look at it if I have a very good listening audience. Yes, I have Patrick points, Priscilla points, Andrew said polygons. That is different from point. Yes, that is to tell that people are listening. Point from Christian. Bright said points. Joseph Quay says polygons. Now let's review the cache. So this would basically give us another person, Cecilia Akron said points. Let's see what we have. So for a small scale map, here we are looking at, we are not interested in details. Okay, we are not interested in details. So we are looking at a scale very small. So we are looking at generalization of our features. All right. So here our answer reveals that we are going in for points. Points. So that the simple explanation is that we are not interested in the size of the heritage sites, the details, whether there is vegetation cover, if it is a monumental site, whether you want to see the locations of some monuments in the locality or not. We are looking at a very large area, so we pick a small scale. All right. So here, all polygons will even be seen as points. So a typical example is if you are looking at the World Heritage Site for, let's say, the whole of Africa. Okay, where you see, for instance, Kwame Nkrumah Mausoleum will be seen as a single point. So the answer is points. Points. Let's look at quiz number 2. Here we are looking at archaeological sites. Archaeological site. And archaeological sites here are areas that are within a small area. Okay, so let's say within a 2-kilometer radius. Okay, for let's say a small area, some part of Western North region of Ghana. And here the question is, this archaeological site, maybe you are the geospecialist that is manning the area for that particular project, and you are doing some archaeological, you are excavating some archaeological items, all right? And then the question is, if you are asked to develop a map of that area, okay, what kind of geometry would you use to connote or identify these sites? Mind you, the area is very small, within 2-kilometer radius. All right. Are you going to use polygons? Are you going to use points? Or you are going to use lines? Then again, in the next 2 seconds, answers please from my audience. Right? Somebody says polygon. Alright. Polygons from Bright Homla. Priscilla says polygons. Yes. Any more answers? I'm getting quite interesting answers here. There is a small area. Of course, we are interested in details. Okay, interested in details. So here we are looking at a very large scale, and therefore we go in for a polygon area. Sorry, polygon geometry type. Polygon geometry type. Right. Great. Now the next thing is, what type of scale will be used? What type of scale will be used? Are we looking at small scale? Are you looking at large scale? Can I have my audience engaged? I have very good audience in class. Can I have them engaged? Are we looking at large scale or small scale? Yes, I'm seeing Aura large scale, Priscilla large scale, small scale from Benjamin Opoku. Yes, that's a different one from all the answers that I'm seeing. Please, any more? Hamza, large scale. Good. So let's reveal our answer. So for this one, we are looking at details. So we'll go for a large scale for that kind of map, right? Thank you very much, audience, and my class is very attentive and responsive. All right. We'll be wrapping up very soon. The next scenario is we are looking at roads. You are to construct some roads. You are creating a map of Ghana showing the national highways. The national highways, basically the major roads that connects two cities and then, or two cities or two regions, all right, into the mainland of Ghana. So what type of geometry would you use for these road features? Are you going to use points, lines, or polygon features? Then again, in the next 1 to 2 seconds, I want to engage my audience again. Right. So I'm seeing lines through. Yes. My audience are very good and I'm seeing them paying attention to the delivery. Well done. So, of course, we go for a line or a linear geometry. Okay, great. So what type of scale would this be? Is it going to be large or small scale? Here we are looking at, we are creating a roadmap for national highways. So we are looking at the whole, typically the whole of Ghana. So my audience, let's pick some answers. Right, I'm getting some answers. Yes, small scale. Andrew I says large scale. Yes, that is the only different answer I'm seeing here. Ora says small scale. Priscilla says small scale. Yes. Wedi says small scale as well. All right, so let's reveal our answer. Of course, if you are looking at a very large area, then we go in for a small scale. Thank you very much, audience. All right, so let's go to some true or false questions and then be sure that we are actually in the flow. So the first one is, just tell me whether this is true or false. Real world features may be represented by different geometries. That is points, lines, or polygons at different scales. Is it true or false? All right. Then the next question, each real-world feature can be represented by a single geometry type, points, lines, or polygons in a map. True or false? Then the next question is, cities should be represented by point features at large scales. Listen well. Cities should be represented by point features at large scales. Is it true or false? All right. So we have quite a number of answers. Okay. That is interesting. Right. So we have quite a number of answers here. Very interesting one. But let's reveal our answers. Okay. So yes, real world features may be represented by different geometry types. Points, yes, that's true. Okay. Real world features can be represented by single geometry types. All right, in a map, that is false. Cities should be represented, the word there is should be represented by points featured as large scales, cities for large scales, all right? And then the local parts should be represented by polygon as small scales, right? So if you have a small scale, then we are looking at a lot of details. So that is true, right? So let's move on quickly to our raster data model. That is another set of data model that we use in storing our GIS data. So a raster data model is a way of representing your spatial data model in a form of grids, which we call pixels. And these pixels are in some rectangular shells, which you also refer to them as cells. So each cell or pixel in the grid is assigned a value which we refer to as a cell value. So we look at some examples of these raster data sets. So what we have on the screen is basically a raster data that has been zoomed in. So when you zoom into some extent or some scale, it becomes pixelated and you see the data in the form of grids. And these grids is what we refer to as what? Cells. And each cell is assigned a value. And the value assigned to the cell is what we refer to as a cell value. So data is stored in these cells. Okay. So if you see a satellite imagery or a drone imagery of an area, okay, it is made up of collection of these cells or pixels. Okay, and these pixels can be this data set, the raster data set can either be a single band or a multi-band. I'm not going to go into that detail. So these are the bands. We have band 1, band 2 to band 4, and then we also have some other bands. All right, I won't go deep into that. So this is a typical example. So raster representation of the real world or a representation of the real world into a varying continuous data, okay? It's what we refer to as raster. And we said that the vector has discrete boundaries, well-defined boundaries. But these raster data set, their boundaries are not well-defined, okay? But nature, they change over time. A typical example is when you have weather data. If you have weather data, now, that is what you may have it. So we can have areas that are more red as areas that are in, let's say, areas that will be experiencing some harsh weather condition like rain, storms, and areas that are, as the color gradients differ a little, like light, red, meaning that the severity of the storm or the rain in that particular area will be less. And then as you move further away from the red color, it shows you the severity or intensity of that particular data. In this case, if you're looking at weather, right? So all the colors we see with your eye is actually made up of little cells or boxes, which we call pixels. Let's, just like we handled, let's look at some properties. So raster data also have property. So they are organized into a matrix or cells. So one of the property is that they have pixels or they have cells. Those rectangular boxes you see there is a property of a raster data. Each cell in the grid is assigned a value. So each cell should have a value. And these values are collectively representing the characteristics or attributes of the geographic area that is being modeled, right? So if you have a weather data of an area, each of the pixels has a value, and of course, values with some other information, right? And that information is what forms the attribute information for the raster data. And this kind of data, it is commonly used in remote sensing and also in GIS application, right? So raster data types. We have first one, which is a continuous raster data type. So a typical example is DEM, that is digital elevation model, where you have the height of an area that has been modeled within or modeled in a GIS environment. So areas with very high color gradient indicate very high lands. Areas with high altitude or high lands, so to speak, right? And areas with very light color gradients are areas that are low lying, right? There's another example. So if you look at the map of Ghana, so areas where we have very gray area colors are areas that have low lying. So if you look at the Volta Lake areas, part of Eastern region, these are areas that have low lying, right? And as you move up, right, the part of the mountains and then part of Western North, you would realize that the color changes, and then part of the even the Western region also, right? So these are some properties of the raster. Now we can also have what we call static raster. So this is a typical example of a static raster where you have a map of an area. Okay, you take a photograph or you scan a map of an area. This becomes a typical example of a static raster. That means that even though it's a raster data, it does not change. It becomes static. The data will not change, unlike the continuous raster where the data will change over time. Typical example is the weather. So after some time, you see the weather, the area of the weather of an area becomes very, cloudy, and then over a period of time, the clouds, go away. So it changes over time. Whereas if I take a photograph of, let's say, a vegetation cover of Ghana, and then, or I scan it into a paper form, it will be there for 100 years and over, and it will not change. That data will not change. So a typical example is a scanned image. Right, great. So that brings us to the two data models, and then we want to know whether we really have understood. So just want to engage the audience a little by looking at some quizzes. So we are going to categorize our spatial data set either as vector or as raster. So when you are presented as a GIS analyst, when you are presented with data or when you collect data, would you be able to differentiate the data set, whether as raster or as a vector? Let's see if we have a very good listening audience and our audience are in class. So consider the following data descriptions and determine whether they are discrete features or continuous phenomena. So discrete means they are vector. Continuous phenomena means that these are raster data set. So let's go on. So when you have, for instance, annual rainfall, because of time, I just want to limit a lot of the animations and move on. So when you have data like annual rainfall, is it going to be continuous? That is raster data or a vector data, right? So a continuous raster or continuous data means that the data changes with time. Okay, so rainfall, is it a raster or a vector? In our case, rainfall data is a continuous or raster data, right? When we have air temperature, so air and then temperature, so either air quality, temperature data, is it continuous or it is a vector data? And this is a continuous or a raster data. If you have some road data, is it a discrete, which is vector, or it is continuous or raster data? So our road data they have well-defined boundaries, and therefore they are discrete in nature and are vector data model. Data on hotels, weather points or polygons, these are also discrete or vector data. When you have data on slopes, hill shades, these are continuous data or raster data because they are not discrete in nature, and then they change over time. All right. Voting districts. So we have a district that has been deemed a voting district. And this is a typical example of a discrete data because a district data is a vector data. All right. Utility infrastructure data, this is a discrete data as well. Soil data is a continuous or raster data. And then we have addresses. These are also discrete or vector data sets because they are definite. They have boundaries. So for instance, if I give you my GPS address and then you put it in the GPS Ghana Post locator app, and then you zoom into my location, the address of your destination is definite. It is discrete, and that makes it a vector data set. Right. Good. So we'll move on. So GIS spatial data model, right? We said that the GIS uses location and attribute information of a place or spatial data. Now, storing this information, okay, gives us two definite items, the where and then the what of where something is. I want to repeat it. So your GIS uses location and your added information, which is your attribute information. Okay, it gives an information of that spatial data, and it does that by storing one, your where, and then what something is. So your where basically is your spatial property or entity, which is your location, where, your X and Y. And then the what gives you the added information of the where. So here we are looking at the attribute information. So typically, we're looking at John here on our Ghana card. He is a Ghanaian born, bred and battered in, specifically in the Ashanti region. So you can see him here, Rowan Atkinson. So he's John citizen. So if you look at this sample data we have on the screen, you can deduce a lot of spatial entity or spatial data from just a simple Ghana card, which belongs to John citizen. So typical example, you can have his name, you can have the date of birth, the class of the license, the date of issue of the driver's license or the Ghana card or the identity card, the nationality, the reference, the license number, the address, which is a digital address. Okay. Now you can actually have the where, which is the location of John citizen, where he lives. So if I'm able to put in this address in some sort of application, I'll be navigated to his home. I'll probably find him in his house, maybe in his bedroom, taking some popcorn and watching some Netflix or some, movie of a sort. So just by looking at a simple identity card, you can actually infer the power of GIS in that particular card. So here we can infer the location of John citizen by just simply looking at the address. And here I'm referring to the digital address or the postal address. And then we also have the what, attributing the where of our GIS information. And here we are looking at his name, the date of birth, the class of the license or the identity card, the date of issue of the identity card, and the nationality of John citizen. Right. So just by looking at the card, that is what you can infer. And that brings us, that actually gives you or informs you of what GIS is used, where GIS is used. GIS is used in almost all our lives, every aspect of our lives, in terms of our operations, in terms of what we want to do, right? So that is GIS. So we've been able to look at one, what GIS is and what GIS is not. And then we've been able to look at some concepts of GIS. We've looked at the component of GIS, application areas of GIS. We've also been able to look at the data model or the data that goes into GIS, right? So we'll be looking at some applications or GIS software, right? Here I'll be taking you through, because of time, I'll just touch on them. And then in our subsequent series, we'll be handling them in detail. So we have two GIS applications. We have what we call the Esri ArcGIS software, which is the ArcGIS Pro, and the Quantum GIS, which a lot of us call QGIS. Okay, so these are the two applications. So one of them is proprietary, that means it's paid, and then the other is free or open source, that we know it. But in fact, both of them are actually open platforms. Let me put it that way, right? Right, just a quick recap. Then we'll look at questions for the next 10, 15 minutes. So we've looked at what GIS is, fundamental concept of GIS and application areas, the component of GIS as I indicated, the spatial data types, and then we looked at a brief look at the two GIS software, right, which we'll be using in our subsequent sections in our introduction to GIS series. And we'll be looking at how to demo using these two applications specifically. There are a lot of GIS software out there, but we want to be concerned ourselves with these two. And then we would demo, we'll have a live session, how these application software can be used to manage data, to display and visualize data, once you have the right kind of spatial data. Thank you very much. At this juncture, I would like us to take questions in the Q&A section. Right. Thank you. And Q&As. Please, if you have any question, I think at this point you can unmute, or if you are in an environment where you cannot talk, you can type. Andrew, please unmute yourself and then you can speak.
Yeah, good evening, and thank you so much for this insightful program. I'm really, in fact, I always want to get an opportunity to go through this GIS kind of thing, because I do hear it all the time. I'm a geography teacher, but I have not really gone lessons and all that. But today I've really gotten a lot, and my question is that the QGIS and then the ArcGIS, what is really the difference in them? And must you have experience in all of them before you can be able to, yes, must you have experience in all of them before you can be able to maneuver GIS? Thank you.
All right, thank you very much. So we'll pick the next question if there is any. I want to answer two because of time. I want to answer them maybe batches of two. Are there any questions from our audience? So yes, Andrew has asked a question as in the usability of the two. Do you need to know all the two? Must you have knowledge in both? Any other questions so that I can pick them in a row?
No? Yeah, my hand is up.
Yes, please go ahead.
All right. Thank you very much for this insight presentation. I am Ramson, and I'm joining you from Israel, and I want to ask, in your line of operation as a professional, if you want to do a local project in Ghana, let me say in Ghana specifically, what has been some of your challenges? I mean, if you are locally doing that kind of project. All right, thank you.
So we are looking at challenges in GIS implementations, right?
Yes, especially when you are doing a local project.
Okay, okay, all right. Thank you very much, Ramson, all the way from Israel. So, any other question? Or I picked the two.
There is a question, sir. Good evening.
Okay, good evening. Your name, please, Hafiz.
My name is Hafiz Yahya.
Okay.
I'm joining you from Wa.
Okay, good to hear you.
Anyway, I
Okay.
joined late, but I think I have benefited a lot from this lecture.
Thank you.
The question I want to ask is, so what is basically the uses or the application of GIS in the security sector?
Okay.
Like how beneficial GIS will be in the security sector?
Okay. Thank you very much. So I'll answer that for you in a moment.
Yes, sir.
Okay. Okay, so let me just pick these three, and then we can pick the next row of questions. All right, so the first question was from Andrew, and Andrew wants to find out the difference between QGIS and ArcGIS in terms of whether you need knowledge in both to be able to use them effectively. The answer is yes and no. I want to pick on yes. So to be able to use any application, even if it is not GIS, you should be able to, you should understand, you should be trained on the use of that application, especially if the application entails some tools. And in most applications, there are tools for you to navigate the application. So you should know what the tools are for, how to use them. So you need knowledge in both. However, if you use one GIS software extensively, then maneuvering your way around another similar GIS software becomes easy. That is why for instance, unless I am on a project and the project requires that I use a particular software, GIS software, I will go in for the Esri's ArcGIS software or the QGIS. These are the two most widely used GIS applications for data management and then also for data processing. Right. Unless, of course, I'm doing a heavy lifting image analytics, then I'll specifically go in for a particular software, a GIS software that would help me manage that raster or raster data effectively. Okay, so some of the GIS software, even though they can display some of the data models, especially the raster, if it comes to analytics, some of them will be limited in functionality as to what to give you, the GIS analyst. So then you go in for specific software tailored for remote sensing, and that will give you all the needed analytic tools that you need for your projects, and that will not stretch you, to want a better word, right? So you need knowledge in both. And then also, if you have knowledge and experience in one, it is easier to be acquainted with the other when you are presented with any GIS software. Right. Thank you. I hope I have attempted answering that. Right. The next one is from Israel. Right. I think our audience or our participant mentioned challenges in implementing GIS projects locally. Now, for application and implementation of GIS locally, typically in Ghana, it cuts across globally. All projects have challenges. All projects have challenges, right? So for me, I would typically use myself an example in my line of work. The most challenging parts would be, let's say, the infrastructure, the IT infrastructure. And in some cases, we look at even the data. The personnel and the software will not be a problem. But these two components, I'm speaking in the perspective of the component of GIS. the infrastructure may not be there. The data may also not be readily available. Sometimes you need to mine the data, you need to collect the data. So we are looking at primary data or secondary data. So in most cases, when you are faced with these challenges, it's very difficult to navigate your way around, especially when you are working in a local setting where there is limited data, unlike other jurisdictions where data is readily available. You can have data on free open portals where you can actually go and fetch data and use. And most of the data are up to date. So running your analytics on them becomes very easy. You get the right kind of result or feedback when you run these analysis on them. So in terms of challenges, there are plethorial, numerous and plethorial challenges that you would have in your implementation. However, you as the GIS project manager or implementer or analyst will need to find a way to mitigate this. So I cited two examples of challenges will be data and the infrastructure, right? Because the personnel and the application or software, sometimes you have control because you will be using them, right? And then in most cases, capacity, when you are building capacity, sometimes even project owners do not see the need for them to be trained until a point where the maybe top level managers would enforce or entreat them, or they'll need to force them to use the system, and that is where they come running, right? So most of the time, you need to let your owners or the project owners understand, or stakeholders understand the importance of your deliverables to their day-to-day activity. By that way, they will take the capacity very seriously and then align with your deliverables, right? Great. Then Hafiz also mentioned application areas in security. But when we started, he said he joined along the line. We touched on security, right? We touched on security. I just want to, security, I mean, GIS application in security, or GIS for security, which we call the GeoIntelligence, the GeoInt. It can be applied in so many areas, so many areas. So here, I just want to speak to, so here we can talk of analysis of, let's say, crime. So you can have all areas where there are some sort of crime, maybe some bad person is killing or adopting some people, right? And then you can actually use the application of GIS to map these locations and then analyze the locations and activities of these perpetrators. And you'll be able to preempt by either using predictive analysis to be able to preempt, either using predictive analysis to even determine when will be the next action or the next activity to be taken by this, want of a better word, bad people. So that is one application. We can also use it for fraud mitigation, right? So if there is some sort of fraud, it can be internet fraud. And you know, when you are using your laptop, you are using your computer, your IP address can actually give your location away. So you can either run some kind of analytics, and in most cases you can do, there are a lot of things you can do, social media profiling, to be able to even determine the sentiment of people who use social media. Be able to determine what people are doing, the kind of discussion people have on various social media platforms, and be able to tell whether these people are discussing any kind of security risk, subjects. maybe they are planning something. So GIS can be used in that area. Fighting fires, okay, security, all right, it can be used. I talked about auto theft, where people steal cars in some jurisdictions. You can also map the locations of all areas where these are happening. You can also deploy some sort of crowdsourcing application, which we'll be doing as a group, as GeoInt group. One of CPDs will be to come up with some social interventions. And I wanted to mention this at the tail end of this particular delivery. So we'll come up with some social intervention where we engage the citizenry on some of the security issues. So for instance, if there has been some burglary, some theft, some kind of maybe somebody is stealing street light bulbs, okay, and then you are in your room or you are driving by, and then you have an application that is sort of engages the citizen, right? You can just log into that application and then submit some sort of information or data. You can take a photograph, you can take some short videos and attach it. And this information or media will go to their respective security services. And immediately, once they also have a system, which may be either a NOC or a network operating center, they will be able to tell where this feed is coming from. The location of the feed is picked or is taken, and then they are able to tell what is the nearest police, barrier or the police post to attend to whatever situation that is happening anywhere. So we said that GIS empowers where and what. So these are some of the application areas, and there are a lot of them. There are a lot of them for mission planning in terms of defense, for tactical planning, for warfare, what is happening, in the world in terms of nation fighting against nation. They are employing a lot of GIS application. Launching of RPGs, that is rocket propelled grenade. Okay, the rockets are equipped with the locations, or the grenades are equipped with the locations of where they have to land. Drones that are used for warfare and all that. So GIS cut across. Application area in security are a lot. If you give me opportunity, I can talk the whole day in that regard. Application areas, right? So I'll pick some questions. I'm told some questions are also in the chat box. So I'm seeing what are the current challenges on the use of tools in GIS in Ghana. Yeah, the challenges are a lot. I mean, I did mention that in my area or my line of work, GIS some of the challenges that we are faced with basically will be data and then also platforms. And then in most cases, we can also have capacity transfer of the knowledge. Yes, and in some cases, even if GIS actually reveals the truth. So in application of GIS for M&E, which we term Geo M&E, there are projects that we actually use GIS to reveal some hidden truth in some project interventions, and then in some cases, the owners even tell us, or the stakeholders tell us, you are giving too much information, to try to mask some of the information. That is the power of GIS. It tells you what is happening where and how to even mitigate them if there are issues, right? Somebody, Edwin, says that is GIS used in military? Yes, GIS is used in military. And we are trying, in the Ghana Geospatial Society, trying to engage the security service, right, to employ the use of GIS in their operations. There is a full-blown application area for defense. So for tactical planning, for mission planning, for warfare, right? All these application areas are made possible by the use of GIS, right? Good. Another question said, in terms of security, I can testify here, we are being alerted of incoming missile. Okay, yes. Yes, so that's Ramson from Israel, I think. So missile based on your location, so you can enter into the shelter. So that is exactly what is happening with GIS. Okay, if you have a very good crowd engagement application developed from a location-based application, you can engage the citizenry. Okay, because if these missiles are being launched, they are landing somewhere. They are from somewhere, landing maybe from some military base somewhere, or from a drone which is flying overhead, or aircraft which is flying overhead, and they are landing somewhere. They have fixed targets. So with the application of GIS, you'll be able to know where they are landing, inform citizens, if need be, through some sort of citizen engaging app, right? And you'll be able to mitigate a lot of death tolls and then effects, negative effects. Somebody asked, Abdul says, what are some regulatory guidance on GIS in Ghana? Okay, what agency or states, what state agency regulate the use of GIS in Ghana? Wow, that's a lot. So that has to do with policy, right? Currently, I know Ghana, some agencies like the Land Commission Division, Ghana Statistical Service, and then some government institutions that make use of spatial data are trying to put together what we call spatial data infrastructure. There is a policy framework that actually stipulates how GIS data is used, what GIS data should be used together with the Ghana data protection. I'm not sure the extent of progress on this particular project. I was privy to review some of the document, but we can look at it maybe in our subsequent sections. We'll try and see if we can get some subject knowledge persons to speak to these GIS policy, but it has to do with NSDI. Some jurisdictions have NSDI. I'm privileged to be part of some conferences where these NSDIs have been launched, and we looked at some of the policy documents and all that. So these are policy framework that governs the use, the source, and the application of GIS data. But in Ghana, we are still working at it, I believe. Yes, we are working at it. Thank you very much. Let's see if we have some questions or anybody with their hand raised in the audience. We've gone a little over our time, but I believe it's worth it. Any more? Yes, Andrew Ayi raised his hand. Please lower your hand and then unmute.
Yes. Sometime last year, December there, I wrote an article in the Daily Graphic concerning how GIS can be used to flash out the disturbances in the northern part of Ghana. I don't know whether you've read about it. I also again wrote about how GIS can be used to curb fire outbreaks in the country. So far, Daily Graphic was able to publish only the terrorism in northern Ghana.
Okay. So that has to do with conflicts, right?
Yeah, conflict in the northern, or let me say terrorism, because the article was under terrorism in northern Ghana, how GIS can be used. But they were only able to publish that and left out this. But I can say and add up to so far what has been discussed is that GIS is quite expensive to run, if I should say that. And so most countries, specifically in Ghana here, find it very difficult using it. If not that, then I will also say that probably their ignorance of our agents, some of our agencies are really ignorant about this GIS that we keep on talking about. That's what I can say. But my question is that when are we going to have the actual application? How we can use a GIS is how to use it. Probably one day you can come out and show us how we can use it itself. Now we've gotten the theory about it, but how can we use it? How can we manipulate it? If we are homes alone, how can we use it to map up probably Labon that I live? How can I use GIS? If I'm in my room on the computer sitting by my set, how should I be able to use it? I hope one of these days you come out to show us that. Thank you so much once again.
All right, thank you very much, Andrew. Yes, so yes, I did mention that is a series. I mean, we are looking at introduction to GIS. We have about three, if I'm not mistaken, three series. From what I shared my earlier slides, where we look at the basics, we look at the spatial data proper, we look at displaying data mapping and visualization. We look at geo analysis as well, and then I think map creation. So it's a series of lecture or training that, if I may say, that we are running. But we will also try as much as possible not to take out the GIS companies that are GIS companies that are in the business of training out. In as much as we want to churn out, we would love to train. We would love to churn out a lot of information. Okay, so application, of course, it boils down to the use of the application boils down to the training capacity, right? So you need to build capacity along a particular area. So if you are looking at remote sensing, then you build capacity along remote sensing. If you are looking at GIS, you build capacity along that as well. If you are looking at both, you do that. So you really need to invest. That is why you said it's expensive. You really need to invest in capacity to be able to. So simply mapping POIs or point of interest is easy. Maybe one of these one of our CPDs will look at it, develop simple smart forms or smart data collection forms or ODKs, and then we'll look at collecting data. Now, GIS data, you can either man it sitting in your room, or you can go to the field and collect it, or both. So it depends on what the project deliverables are, what the project is looking at, and then you provide the needed support. Yes, so have three hands up. So I'll start with GS Gamali Agbada. So GS, please, if you can unmute, lower your hand, and then you can speak.
All right, thank you very much, Richmond.
Thank
that
you.
was a very insightful presentation. Mine is not a question, it's just a little addition to your submissions. This has to do with the question that the previous guy asked about how do we use the GIS. First of all, I would like to say that GIS, first of all, we need to understand that it is not just a software. As Richmond has made us understand, it is a system. We say geographic information system. In what we know, every system has components. So let's take using of Google Earth or Google locations, for instance. The hardware there is your phone. The software is what is actually showing or displaying that map that you are seeing. You want to move from point A to B. So you've got your hardware, which is your phone. You've got a software, which is doing the display. You have the data, which is the road map, and the location map, which is the data that has been collected and put or hosted on that software. Then you have the people, that is you, who is using it, right? Then the fifth component will be procedure. Now, GIS is something that we've all been using already. Maybe it's just that there's always been this notion that when they say, do you know GIS? Where everybody's mind gets to immediately is that the software. No, but that is one part of it. Because people say, oh, if I know how to use ArcGIS, it means I know GIS. No, you'd have to understand that the ArcGIS is just a software, one of the components. How do you call it? Quantum GIS. And so many. There are 1,001 GIS
application. Yeah.
So if you're able to understand that there is a system and putting all these systems together to help you make an informed decision, then you're actually doing GIS. So it only depends on exactly what kind of accuracies that you want, what kind of results that you want. Because what is it that we are looking at? Let's take a bank, for instance. A bank is issuing out loan to people. They already have of their customers. They have their first name, middle name, last name, address, but they're all in textual form, which means that they're able to tell who is who. But if they don't add a geographical data to it, it becomes difficult for them to know who is coming from where to bank with them. Now, talking about giving the loan, let's assume that the bank decides that, okay, anybody that we give loan to, we will track his location. Maybe the person defaulted in the loan. Maybe person B did not default. They keep collating that data until it gets to a point where they have so much geographic data, their geodatabase. Now they've come to realize that there's a certain trend that people in this particular area, Z, they like defaulting on loan. The next time somebody from that area comes up that I want loan, quickly the bank will make an informed decision. Should we give it to him? Or should we give it to him with high interest so that even if he runs along the line or he defaults along the line, we'll be able to recoup something? So you can see clearly that the bank has just used GIS to make an informed decision based on the data they have collected and analyzed. So in a nutshell, I just want to add this, that let's see GIS as a system, and we are already using it. We just have to read more about it and see how best we can make it work. Thank you very much.
All right, thank you. Yes, Kamali. Okay, so we'll move on to GS Abigail Amoa. Please, if you can hear me, just lower your hand, unmute and speak.
Hi, good evening.
Good evening.
This session has been very, very, very insightful. I've enjoyed it throughout.
Thank you.
You mentioned that there are some GIS training groups that you think that if people want to know more, they can join. So if you could give us some of them so that we can share with our colleagues at work and other places.
Okay.
And I also saw you that you've displayed, this one is, I've just been inquisitive. You've displayed your, I don't know whether it was, you just showed 3D drone, something like it was full of buildings and
yes, my
I want
desktop.
to find, yeah, your desktop. I want to find out, is it a resettlement community or what is it?
Interesting. So it is not a resettlement community. It's a project that my company worked on. So basically, just a gist about the project is to identify each of these folks, whether they are using some sort of a product that an organization sells. So it was some kind of business analytics we built for the client, right? So each of these, so we mapped them, we flew a drone, you can see the 3D, and we're looking at certain, so you can see the poles. All right, so we're looking at the use of fiber, okay, in these homes. And then the fiber company has installed gadgets on the poles. So they want to find out how many people are being served by each gadget on the pole, by each home. So that is a nice settlement. This was done around Community 25. So, and we built some analytics for them, right?
Okay, so it's around Community 25.
25.
Okay, the reason I'm asking is that we are embarking on a resettlement project, and I see these designs to be very nice. We are actually struggling to agree on some building design, so I just saw this and it took my attention a bit. Yeah.
All right. So maybe you can contact me, and then we'll look at it. If you're
Okay,
looking at redesigning, yes, you can look at it. One other application area is redevelopment, redesign. So we can look at it. Thank you.
Thank you.
Right. And then before Godfred comes in, yes, I mentioned that there are organizations that organize GIS training, quite a number of them in Ghana. So for continuous development and also continuous knowledge acquisition, you can contact some of them. I'll leave my email address, or I can be reached. I mean, I'm on the Ghana Geospatial Society platform. I think all the working group can be found there. So you can also reach me, and then, or simply go to Google and then type you want GIS training. A lot of GIS organizations will come up, including the company that I work with, right? ArcGIS Spatial. We also organize periodic training. That we did our second quarter training about 2 weeks. We ended 2 weeks ago. So that is why we can get a lot of capacity, and then also build knowledge along that line. So it can either be for organization, for the general public, or even individual working, depending on what you want. Right. Thank you very much. Please, Godfrey, your hand has been up for long. Forgive us. Please lower your hand, unmute and speak. Thank you.
Okay, good evening, sir. And I want to thank you for these lectures. My question is on how can we use GIS to minimize the illegal mining in our forest reserve and on water bodies, since GIS is more about mapping and visualization. Thank you.
Thank you very much, Godfrey. Okay, so before I go to your question, somebody hinted me. So there are other online courses that you can have. I am an Esri biased person because I do a lot of Esri, and Esri has a lot of GIS training, which we call the MOOC, the Mass Open Online Courses. They are free. They come with certificates. So you can sign up. You can contact me if you want. I can take you through how to navigate your way there. Some other online platforms, learning platforms or LMS, like Coursera, Udemy, EDX, and even Microsoft. These are all LMS or learning platforms that run some of these data science, GIS, data analytics courses. But because Esri develops one of the flagship GIS software, they have well-structured GIS courses, which they deliver. Some of them are paid, some of them are free, right? I work with a company that's an Esri partner in the sub-region. That is why we run training. Our trainings are instructor-led. Most of our trainings are led, facilitated by Esri instructors or Esri certified instructors, so to speak. So I can maybe put some of the website in the chat, www. Let me just pick it from the URL and share with you directly. Okay. So there are a lot of online, but you can also walk in and then you get trained. Let's see if I can get some of the resources for you. But as I said, you can always connect with us, and then we'll be able to access you. Okay, so I'll share some of the resources. Sorry, I'll share some of the resources as before the end of this lecture. Right. So you we touched on Godfrey asked whether GIS and how it can be used for illegal mining, right? So one of the application area is mining, or the I touched on small scale mining. I didn't want to have problem to do with anybody. That's why I didn't touch on illegal mining. But illegal mining can be the problem associated with it. Okay, can be mitigated with GIS. And as we saw from the application, you get to know where these activities are taking place. You can even use GIS to look at the rates of devastation of the green areas, in this case, the forest reserves, over time. And that should inform you as a decision maker that if we do not go in and then stop it, in the next 3 or 4 years, we will need to import water from other countries to be able to survive, because they are destroying the water bodies. So with GIS, you look at the location of these activities, the rate of spread of the devastation. Okay, you would also be able to deploy a lot of applications, including hardware like drones, like crafts, okay, to collect data to help you, make informed decision, right? If there is a need to even train these non-artisanal small-scale miners, which we call galamseyers, you can use GIS to collect data on these and then try to, as it were, train them in proper and right way of mining. By so doing, you are not stopping them, you are not sacking them, but we are trying a nice way to also let them integrate into the small scale mining so that they can do proper mining, what they call proper mining. So GIS can be used to do all that. And you can monitor them with GIS as well so that it becomes sustainable. So areas that you need to even plant trees, because you have data and you have analyzed these areas. What is the size in terms of maybe acres, hectares, square kilometers, square miles, okay, of areas that have been devastated with these activities of these illegal miners? And then what can you do to plant by way of reforestation? And even if you plant the trees, you can actually use GIS to map each tree you plant and monitor the growth of each tree. All right, most of the time we just plant the trees and then we walk off and expect the trees to do well in the wild. Some trees will not do well, some trees will need care. So with GIS, you can actually, in some jurisdictions, if you go somewhere, each tree on each street, which they call avenue trees, it's on a map, sitting somewhere in the database, sitting somewhere. So even if there's a storm and the tree it's uprooted by the storm, or the tree it is felled by the storm, an organization or the institution responsible for that tree knows that the tree is no more, is not in existence, or it has fallen, or it's broken, something, and they attend to it. But in some jurisdictions also, we do not care about what happens in space. And it goes a long way to affect it because it's an ecosystem and we are part of the ecosystem, it cannot be taken out. So yes, GIS can be used. GIS can be used, and the application areas are a lot. So we can even look at which river bodies, the location of these river bodies, where they are on the surface of the earth, or in Ghana, if we are using Ghana as a project case study. Okay, which forests are these rivers? Okay, you can run buffers to identify the how do you call it, the rates and even the extent of damage to these rivers, by proxy the forest. And then if there are any mitigation factors, you can also use GIS to plan and execute them. So GIS can be used in curbing that menace. Right. Thank you. If there are any questions, are there any questions? I think we are far spent to our time. Just like I said, it's a series, so there's always room for more. Please, any question, any more questions? Okay. If there are no questions, I would yield here and then hand over to our moderator. Priscilla, over to you. Thank you very much, audience. I'll be putting in the chat box some resources in a moment so that we can look at it. Thank you very much.
GS Richmond, thank you so much. From the response in the chat, I think we can see how insightful this program has been. Thank you very much for giving us a bit of your knowledge. We are really grateful.
Thank you too. So, yes. So just like I said, we'll be running the other sections. The date will come out. The dates have been confirmed, and then they'll be coming out very soon so that we can also plan and be part of it. Thank you once again, and have a nice evening, a nice morning, a nice afternoon, depending on where you are joining us from. And then we hope to see you in our next lectures. Bye-bye.